I would like to introduce myself a bit. My name is Saqib, and I am going to be a host today. I am the product lead at GMAT, and I'm also the principal architect of the GMAT intelligence that is there in our system. So while going through the course, whatever logic that is built in to help you personalize your course, I have been the part of the team that has built the intelligence. Apart from that, I have also close to now 10 years of tech experience. I've been in the industry for a long time. I think I kind of now understand really well what kind of issues most students go through and what are the major pain points. And apart from that, I've also taken these exams. So I've taken GMAT myself. I love teaching QUANT. I've taken the Indian version of CAT also, if I'm not sure how many of you are aware of it, but that's also one of the, I think, the toughest exams in India. So in both these cases, I have done pretty well in quant, and I love teaching quant, by the way. I love to kind of simplify concepts as much as possible. So in this webinar also, what I'm going to do is I'm going to clearly lay down how to differentiate between factors, multiples, how to set up equations, because in most of the DS questions and variable-based questions that Nikhil, Carla, they're pointing out is your ability to do two things. Number one is how well you can infer, and after inferring, post-inferring, the question stem, how well can you set up your equations? If these two things are done properly, most of the time it's after that it's very easy to solve. So we look at particular questions of these type where you may have to set up equations as well as work with variables. The progression of the webinar is going to be similar to the usual webinars. I'm going to spend about 60 minutes. Sometimes it stretches to 90 minutes. So just letting you know now only 60 to 90 minutes on the main part of the webinar. And I usually give about 10 minutes at the end where if you have any questions, general questions related to GMAT or quant, or any question that while I'm discussing and maybe you did not understand and you want me to go through it very quickly, some portions of it, I can definitely do that at the end of the webinar. Okay. So one more thing is that if you're attending this webinar for the first time, this is a part of a series. There are a lot of other webinars that we have conducted, and this is a series which we started from Feb 13th. If you haven't registered for the webinar, I would highly recommend that you do so. If you want, say, for example, WhatsApp invites also, so that we remind you over WhatsApp, I'm sharing the registration link. I've shared it on the chat box. I'm also broadcasting it. You can just fill up this form, and we'll also, apart from sending you mails, we can send you a friendly invite over WhatsApp also. Okay. Don't worry, we won't spam you. We just webinar updates, nothing else. Okay. So we are currently in webinar number 7. Those of you who haven't, say, for example, seen these webinars or attended the first 6 webinars, I'm also sharing the YouTube link where we usually upload our webinars. You can go through them once. Just give me one sec. Yes, Karan, I'm sharing it. So this is the YouTube link. Guys, if you haven't watched the first 6 webinars, and if you're interested in going through it, I've shared the link on the chat box. I would recommend that you subscribe to this channel, because most of the webinars, in fact, all of our webinars are uploaded on the YouTube channel. So you'll get notified as and when we upload any new videos. Okay. And there are a few more tomorrow. It's a CR webinar also. So if you are interested in learning about CR, if you are facing problems related to pre-thinking, which I think is one of the major roadblocks for a lot of students, I would highly recommend that you attend the webinar that we are going to conduct tomorrow. Okay. So let's start about, and let's try and understand what are the various things that I'm going to cover today, and why are we covering this? Why is this so important? So if you notice that I did not name the topic as primes or divisibility or something like that. The name of the topic is factors and multiples, and the reason is if you're able to understand the concept of factors and multiples really well, then you will be able to do well in 3 of the topics. 3 topics, which is primes, LCM, GCD, and divisibility. These are the 3 topics where the concept of primes and factors are like used a lot. When you're doing prime factorization, you would be in primes, you would need to know the concept of factors. When you're solving LCM GCD, least common multiple, greatest common divisor, as the name say, the name has the multiple and divisor in it. So you would be using divisors and factors a lot. And divisibility also, there are a lot of questions which mix the concept of LCM GCD and the concept of remainders to give you questions which are based on, again, factors and multiples. So if you understand this, these three topics would be really easy for you to complete and master easily. What I'm going to do is I'm going to touch on this concept at a very high level. Usually, I don't usually talk about any concepts in any of the webinars, except for the inequality webinar, I think. But I feel that if you don't know the formula of, say, total factors, or if you don't know what LCM or GCD is, then maybe it might be difficult for you to follow this webinar properly. So what I'm going to do is I'm going to touch on these concepts at a very high level, guys. Okay, I'm just going to make you understand what are factors, what are multiples, what are divisors. I'm also going to, once you understand this concept, I'm going to take up a few questions and basically show you how you apply these concepts. Then I am going to, again, teach you the formula of total factors also. I'll show you this, how to find the total factors. And then one question on this. I'll also show you how you need to solve questions based on total factors. And finally, I'm going to give you some questions on LCM GCD. And don't worry, here also I will touch upon the concept of it. So how do you find the least common multiple and how do you find the greatest common divisor? So at a high level, I'll give you the understanding of all these concepts. Obviously, if you want to understand it in depth, I'll let you know from where you can cover that too. Okay, so let's get started with the first part, which is understanding the concept of primes, factors, and multiples. Okay. So there are certain definitions which you should be very, very clear with. One is knowing what are prime numbers. Okay, so prime numbers, if I have to define it in a very simple term, prime numbers are those kind of integers that are exactly divisible by two factors, okay, or two numbers. If you want to really simplify it, you can say it is exactly divisible by two integers. If I want to make it very simple, okay, it's divisible by two numbers. The one of the numbers is 1 and the other number is itself. Now, can anyone tell me from where does prime number start? What are the different prime numbers that you know of? Anyone? It's an easy question, I know, but I would just want to be sure that everybody is clear with it. What's the first prime number? And if anyone wants, they can also write a series of prime numbers if you want in the chat box. Okay, 2, 3, 5, 7, 2, 3. Yeah, good. Okay, so I think it's pretty clear to everyone that prime numbers do start from 2. Very rarely I've seen people talking about 1 also, but keep in mind that's not possible. It's always 2, 3, 5, 7, 11, and so on and so forth. And you can see all these prime numbers are divisible by 1. So if I look at 2, 2 is divisible by 1, and 2 is divisible by itself. Okay, so in short, I can say that 2 has two factors. And since I'm using the word factors, let me make you understand what is the meaning of factors. Now, the word factors and divisors are used interchangeably. That's the first and the foremost thing that you should know about. So where if you see a word divisor written in the question, you can just simply infer that we are dealing with factors only, nothing else. And what are factors? Factors basically are numbers. If I say, let me take an example and help you explain. If I say 2 is a factor of 6, that simply means that this number 2 divides 6 completely. So basically, if 2 is a factor, then 6 by 2 would give me an integer. That's the meaning of it. So 6 by 2 is basically 3. So the factor completely divides the original number. That's the easiest way to understand it. Okay. Now, how do you set up the equation? A very important thing that you need to keep in mind is that mostly in difficult questions, you would be dealing with variables. Okay, whenever you are dealing with numbers, it is very easy to understand. So if I give you a number like say 10, and if I ask you, tell me what are the factors, you might very easily say, okay, the factors are 1, 2, 5, 10. Okay, but in most of the questions that you will get in the exam, they'll give you a statement like this, and especially in terms of variable, that x is a factor of 5. And in my experience, what I've seen is students just read it and move on without setting up an equation. Okay, so if x is a factor, and if you understand this definition that factor divides a number completely, you should be able to understand that. And look at this form. Basically, this is very important. Notice that I'm writing the bigger number up and the factor in the denominator, and that gives me a integer. So you should be able to set up an equation like this. If x is a factor of y, then you should be able to set y is completely divisible by x, and this would give me an integer. So while setting up the equation, either you write it like this, or you simply say y by x is equal to k, whatever you feel like, where k is an integer, obviously, but always set up this equation. Okay, whether you will be using it or not using it, that's a totally different question altogether. But you have that equation with you, then if there's a need of setting up an equation or solving any question, it becomes really easy. So don't just read it in the question stem and move on. Always set up the equation. Okay. Multiples are just the opposite, by the way. So if I say x is a multiple of y, so for example, I would say, let me take a simple example, 12 is a multiple of 6. So in this case, 12, this number, original number, is basically written as 6 times 2. Okay. So here, no, or if you want, you can even write, if 12 is a multiple, then 12 by 6 would give an integer. Either of these two forms are fine, but you need to remember any one of the form. So if I'm saying x is a multiple, so x is a bigger number, that's the bigger, or that is one way of remembering it. So you can say x by y would be an integer. Okay, so if x is a factor, notice it goes in the denominator and it gives you an integer. If x is a multiple, it goes in the numerator and it gives you an integer. If you can remember this form while solving questions, you can obviously logically deduce this in the exam also, not a big deal. If you know it, if you can write it in the form of a number, you just need to translate it in the form of a variable. If you can do that, then that's also good. But you should always set up an equation. Okay. Let me just bring up a yes and no poll quickly. I've been monologuing for a long time. Please let me know if this is perfectly clear. Okay, great. One quick question here. I can see it's clear to everyone. So a quick question here is that, can you tell me what are, if I have to ask you, what are the multiples of, say, 8? Can you just jot down sequentially some multiples of 8? Multiples of 8. What would be the smallest multiple of 8? Anyone? Okay, Anubhav says 16, 24, 32, Radhakrishnan 8, 16. Yes, guys, keep in mind that when you're talking about, when I say multiple, I mean positive multiples, by the way. So those of you are saying 0, my bad, I wanted to know the positive multiples. Keep in mind that you always start from the number itself. A lot of people always start from uh, they always start from 16 basically, and that's a wrong thing to do. So you should always start with, the smallest would be 8. So if I have to look at multiples of 8, I would say 8, 16, 24, so on and so forth. Okay, I hope this part is clear. So an interesting thing to note in case of multiples and factors. Okay, so in multiples, the smallest multiple would be 8, if I'm looking at multiples. In factors also, notice when I was jotting down the factors of 10 out here, notice one thing, that whatever be the number, be it 10, or in fact, let me write up for a prime number also, factors. Whatever factors you consider, the number 1 and the number itself is always a factor. Okay, in between you may have other factors also, like in case of 10 I have other factors in between, but the number 1 and the number itself are always factors of that particular number. So bare minimum you will have 1 and n in that particular number. So that's something, it might not seem very important, but in certain questions, if they tell you that it has exactly 2 factors, you should be able to infer that you're dealing with a prime number. If the question stem says there's a number n which has, say, 4 factors or 5 factors, you should be able to infer that you're dealing with a non-prime number. Okay, nickel 0 is not a positive number, positive integer. Okay, and I was talking about positive integers, nickel. GMAT usually, frankly speaking, will not test you on zero whenever they'll be dealing with multiples. They'll give you they'll give you questions which would be based on positive integers only. So you don't need to worry about zero in case of factors multiples at those kind of cases. It will not come. Okay. Okay, so I hope this part is clear, guys. The other important definition that you should be very clear with is the total factors formula. So if you're not aware of it, first of all, let me write down the generic form, and then let me explain what it means. So, and in fact, let me go back just one slide or back once more. If you notice, in case of 10, if I ask you how many total factors that here, so I'm talking about total number of factors, you would end up saying that there are 4 factors, right? And 10 is, since it's a small number, it is easy to calculate. So 1, 2, 5, 10, you can count it, split it, write it down, check it. But if I give you huge numbers, right, where you have to break it down into a number of forms, so 144 or something like that, or 36 also, obviously 36 is also easy to find, but writing it down manually and finding out the total number of factors is a tedious task. So in such cases, what we do is we use a formula, which is the formula that is being shown on your screen. This might look slightly complicated. So let me explain what's the process of finding it. So for example, if you want to find out the total factors of 10, okay, we saw that it was 4, but how do you get it? So what you do is you write down 10, you split 10 into its prime factorized form. So notice here P1, P2, P3, right? So you have to write 10 and split it into as small numbers as possible till you are left with prime numbers. So 10 can be written as 2 to the power 1 times 5 to the power 1, right? Now, once you have written it this form, if you want to find out the total factors, notice the formula. What is the formula saying? Take the powers, okay? Take the powers, add 1 to it, and multiply it to get the total factors. So if I want to find out the total number of factors, I'll take the power, I'll add 1 to it, I'll take the power, add 1 to it, and multiply it to find out the total number of factors. So I'll say the total number of factors is 4. Okay, so you don't have to manually calculate it. All you need to do is break down into its prime factorized form, and then just take the powers, add 1 to it, multiply it, and get the total number of factors. In fact, in the video lessons, we have also explained why this happens. If you're interested in knowing why do we add +1 to get the answer, I would recommend that you do that, and I'll show you how you can do that too. So here's a simple question. There are no options, but if you want, I can give you 30 seconds. If you want and try this out, you can. Can you tell me how many total factors does 120 have? Keep in mind that you need to break 120 in such a way that you can write it in the form of prime numbers. Prime numbers, prime numbers, prime numbers to the power something. Try to break it down and then take this power, add 1 to it, and then multiply it. So take some time. In fact, take a minute, not a problem. And can anyone tell me what is the total number of positive factors? Okay, Nirmesh says 16, Pranjal says 16, 16. Okay. Okay, so most of you are getting it. So see, that's correct. So what you need to do is you need to again break down 120. One way of breaking it down is, say, for example, you don't have to force yourself to get the prime numbers directly. So as you can see, you can first break it down into 12 and 10. Then if you want, you can break it down into 2 and 5. And 2 square and 3 to the power 1. So you can notice you have 2 to the power 3, 5 to the power 1, 3 to the power 1, 5 to the power 1. Once you have it, you just take the powers, add 1 to it, and multiply it to get the total number of factors. I would again emphasize, remember really, and keep this in mind, that total factors we are getting by taking the powers, not the prime numbers. That's very important. We do break it down in form prime numbers, but it is the power that we are taking to multiply to get the final answer. Okay, this is something that we are going to use in one of the questions. I just want to emphasize this now. And when we are doing the question, I'll show you why this is important. Okay. So since you've understood this, I'll move on very quickly to the next part. This is the last definition that we're going to talk about, and then we are going to move into questions. When it comes to least common multiple, so what we basically means is that we're looking for the smallest number, okay? Smallest number, okay, which is a multiple of 24, 36, and 80. Okay. Now the process of doing it is, so we are looking for a number which is a multiple of all these three. Okay, and remember I told you if I say x is a multiple of y, then that means that x by y should be an integer. Remember this definition? So when I say that find the lowest multiple, that means I'm looking for a number, say x, which when divided by 24, which when divided by 36, which when divided by 80, in all these three cases, it should give me an integer. Okay, so if this definition is clear now, it always becomes easy to think what you need to do. So you have to look for a smallest number which is divisible by all these three numbers. Okay, and let me show you the process of doing it. Let me just write it down on top for a moment, and we'll see why this is important. So what you need to do, the process is pretty simple. If you get direct questions like this, you can get the answer very quickly. Step one is simply to prime factorize all these numbers. So you take 24, write it as 2 cubed times 3 to the power 1. You take 36, you write it as prime factorize it and write it as 2 square, 3 square. You take 80 and you break it down into 2 to the power 4, 5 to the power 1. Okay, that's the first step. Break it down, prime factorize it. Okay. Step two is consider each prime number. Okay, so whatever unique prime numbers are present, you take all of them. So you look at it, you see, okay, I have 2, I have 3, I have 5. These are the three prime numbers. You take them and you take their highest power. So in this case, you look at powers of 2. The highest power of 2 is 4. So you take 2 to the power 4. The highest power of 3 is 2. So you take 3 to the power 2. And 5 is only a standalone 1. So you take 1. So you'll see the LCM would be 2 to the power 4 times 3 square times 5, which gives you 720. Okay. So the process, if you remember these two steps, you can always find out the LCM very quickly. Now, some of these students do ask me, hey, we are looking for the smallest, so why are we taking the highest power? This is where the definition becomes very powerful. So if you understand this, let's write this down here once. 2 cubes times 3 to the power 1, 2 square, 3 square, and x is 2 to the power 4 times 5 to the power 1. Okay. Now, see, if you take the smallest number, like say 2 square, if you take 2 square, let's put 2 square. We'll put the remaining later on, but let's put 2 square for a moment. See, multiple should be a number which should be completely divisible, right? X by y should be an integer. So if I take the smallest power, there are cases where you will not get an integer because 2 square and 2 to the power 4 will cancel and you'll have 2 square in the denominator left. So this will not be giving you an integer. Okay, you have to ensure that you get an integer. So how can you ensure that you get an integer? You can ensure that you'll get an integer if you take the highest power, which is present. So if you take 2 to the power 4, all these three are taken care of. So you can easily cancel it out. You can easily cancel it out. You can easily cancel it out. Okay, that is the reason of taking all the prime numbers also. Why do we take all? Why not just take only the common ones? If you take just the common one, like for example, the only common is 2 out here. If I take 2, how will I divide it? Because I need an integer in this case. If I don't take 3, I will not get an integer in these cases, right? So this is the logical reason because of which we need to take all prime numbers that are present in these three numbers, all unique ones. And that is the reason we take the highest power so that the cancellation happens and we get an integer. Please let me know if this is clear or not. Let me bring up the yes and no poll once. Okay, somebody's saying double sound. I'm not sure what you mean by that. Are other people also facing the same problem? Ideally, there shouldn't be an issue of double sound. Okay, if you have any questions out here, please feel free to ask. I can see 1 or 2 people are still saying no. So any doubts at all, please feel to put in the chat box and I'll definitely help. Otherwise, sound is okay, right? Okay, that's good. So I would request Junaid, I think, to check your sound at your end. Okay, good. So I hope this part is clear, guys. And that's see, the reason I'm telling you why this is happening is because because see, in variable-based questions, these small inferences play a very big role in solving the question. Okay, so if you understand, okay, why are we taking the highest power, or why do we need to take any prime? Why do we need to take all the prime numbers? Then your life would become easy. Okay, Karan is asking, is there any quick way to prime factorize? Karan, usually whenever I deal with a big number, there's no quick way as such, but I usually don't, if I have a 720 with me, for example, let's look at 720, I don't usually do it like this. I don't break down like 2 360. I split it, but whichever number comes first in my mind, which big two numbers that I can split it in, and then I go and solve further. Like 72, I know it's 8 times 9, so I know it's 2 cubes times 3 squares, so it becomes easy for me to club. Okay, so if you want to prime factorize, I would recommend just split the number into two parts, two very big numbers that you can think of, and then split them further. If you start from the smallest and try splitting it, it will take a lot of time. So if you're doing this, don't do it. Okay, that's not a good way of doing it. But that is the only thing that I can, at this point of time, I think would suggest, and this is what we usually do also. Okay, so I hope LCM part is clear. Now let's move on to GCD, and let me rub this a bit. Yeah. Now, as far as GCD is concerned, now here understand we are talking about divisor. So we are talking about factor. Okay. So I am looking for the greatest common divisor. Now, what did I talk about factor? What did I tell you? What are factors? If I say X is a factor of Y, then that means Y by X should be an integer. Okay. And X is a smaller number which divides it. So if I'm looking for the greatest, okay, greatest number, so what that basically means is, in fact, again, let me write it on top only because I'll be using the below space. 24 by X, 36 by X, and 80 by X. These should be an integer. Okay, so I'm looking for a common number which will divide all of these three and get me an integer. So in this case, after the prime factorization is done, the prime factorization is obviously going to be the same. So I'm keeping it like this. Now think about it. If in this case, if I take all the prime numbers, if I take 2, 3, and 5, hypothetically speaking, if I take all of them, will I get integers in all these three cases? And this is a question for you all. I don't want to, give the answer. So let me bring up a yes and no poll. So tell me if the question is very clear. Let me explain the question. If I, in the greatest common divisor, if I take 2, 3, 5, everything, will I be able to get an integer in all the three cases? Will I get integer in all three cases? If I take a number which has 2 also, 3 also, 5 also? No, right? Because obviously if I take 2, 3, and 5, what will happen is, let's say, let me take just 2 and 3, 5 only. So 24 by 2 times 3 times 5. What's going to happen is I will be able to cancel 2 and 3 from the numerator, but 5 will be left. So in these cases, that's the reason we just take what is common. So we here that the keyword here is take the common prime factors in all of them. So the only common prime factor is 2. So you'll take 2, and the power also we have to take the smallest. We cannot take the highest power. If you take the highest power, let's say if you take 2 to the power 4, then 24 by 2 to the power 4 will not cancel out fully because this is 8 times 3. And if you take 16 in the denominator, you won't get an integer. That is the reason for choosing the lowest power. Okay, so that is why the GCD will turn out to be 4. I hope this part is clear, guys. The concept, why we do this, why we take the highest power, why we take the smallest power. I hope this is perfectly clear. If you have any doubts, please feel free to ask. So long story short, if you're dealing with LCM, take all the prime numbers, take each prime number and take the highest power. If you're dealing with GCD, take the common prime factor and take the lowest power. That's all that you need to do. Okay. Now, if you're interested in knowing more about LCM GCD, in fact, factors and multiples, not LCM GCD, my bad. If you want to know more about factors, multiples, I would recommend that you look at the prime numbers video lesson 2 and prime numbers video lesson 3 also. In both these lessons, I've explained factors, divisors. In part 3, I've explained total factors, how to find total factors, how to find odd factors, how to find even factors. All of these have been explained in detail. The good part is that it's available for free trial users also. So you say, even if you're not a student, then you can definitely access this. You just need to register and go and look at these files. So you should be able to learn from it. Okay. So I hope this is clear, everyone. No, see, it won't be LCD, guys. I'm not looking for the smallest number. 4 is the biggest number that will divide them. If we have to look for the smallest number, okay, the smallest would be 1, right? If I have to look at the smallest number, 1 is the smallest number. I would not even need to solve it. If somebody asked me what is the smallest divisor for 24, 36, and 80, I would simply say it's 1. 1 divides all 3 of them. So the smallest divisor is 1. Okay. In fact, that's a good question that you have asked. Keep in mind, sometimes what will happen in the exam is they would give you this 24, 36, and 80. Again, a 600 level question, if it has to come, they might ask you how many, find the number of divisors. In fact, the question would be something like this. Find number of divisors of 24, 36, and 80. Okay. Notice in this case, I am not saying greatest common divisor. I'm just asking find the number of divisors. So can anyone tell me how would I solve such a question if I'm given find the number of divisors of 24, 36, 80? Because the process that I've taught you is for the greatest common divisor. So what should I do next? How do I find out the total number of divisors? Anyone? How would I find the total number of divisors? Yeah, Pranjal, by factorizing GCD number. Very good, guys. That's a good answer. That if you are asked the total number of devices, okay, find total number of devices, the process remains the same. Find the GCD because that would give you the biggest number. Okay, so 4 in this case is the biggest number that divides it. Now, whatever factors of 4 are there, whatever are the factors of 4, they will also divide 24, 36, and 80. So if 4 is the greatest one, just jot down their factors 1, 2, and 4. These factors will definitely divide 24, 36, and 80. So you'll say there are 3 factors. So what's the process? Step 1, find GCD. Step 2 is find total factors of GCD. Okay, I hope this is clear, everyone. So if you get a slightly difficult question, you might have to find this. Let me bring up the yes or no poll quickly. So please mark yes if this is clear, and then we'll start off with the first question. Okay. Okay, that's great. Okay, so here's the first question, guys. Just to repeat the process. Nitin, what do you mean by why 4 if we have 2 already? I don't understand. What do you mean by that? 4 is the greatest number. 4 is the greatest number that divides 24, 36, 80. Okay. 2 is one of the numbers which can divide 24, 36, 80. So if I ask you find the divisor, just the divisor, not the greatest one, just tell me the divisor. So any factor of 4 will also be a divisor of 24, 36, and 80. Okay. So guys, here's the first question. Try it out from whatever you have discussed so far. Just a small request. I'm adding a poll here. You should be able to see it. Please post your response in the poll, not in the chat. Okay, if you put it in the chat, I'll delete it. I'm being very frank here. So if you still want to put it in the chat, send it to me in a private chat if you want to, but not in a common chat. Okay. And I'll give you about 2 minutes to solve this one. This is a 600 level question. Let me look at the chat if I've answered all the queries. Okay, so there's a question, is the cost free or what is the procedure to do this course? The Primes lesson is free as a part of a free trial. Okay, so if you want to just look at the Primes video lesson, you can go to gmatviz.com and register and access that part for free. If you want to look at, say, you want to buy the course and look at the whole course, you use our GMAT Viz course, then you would have to buy it. I've just shared the link with you. You can use this link to buy the plan. Or if you want to try it for free, you should be able to see a button on top right. You can try it for free, look at some of the lessons, and if you find it good, then also you can buy it after that. Okay. Okay, those of you are done with the question. I would want you to do one more thing. Okay, tell me how many values of n are possible, and put that response in the chat box, in the private chat box. Okay, how many values of n are possible? So those of you who are already done with this question, I can see most of you have responded. The rest of you who still have time in the hand, let me know how many values of n are possible in the chat box, and please put it in the chat. That's okay, Deepa. That's totally fine. Private chat, guys, private chat. There's an option to put a private chat. Okay, let me end the poll. I've got most of, in fact, I think that this is a very good response. Almost all of you have marked the answer as B. So this is again a fairly simple question where I've been asked that n is a divisor of 72 and 90. Okay. Now, sometimes people ask me, how do I understand whether I'm dealing with GCD or LCM? These are the keywords that you need to keep in mind. Divisor usually is dealt with, you're dealing with either factors or greatest common divisor. That is all that you need to infer. If there's a question which mentions multiple, then you might be dealing with an LCM question. Okay. So as far as recognizing concerned, these are some of the keywords that you need to look at. Now here the question is simple. I've been asked that n is a divisor. So n is a factor of 72. N is a factor of 90 also. So I'm looking for a number which is a factor of both of them. I told you if you're looking for a factor or divisor, the first step is to find out the GCD. That's the easiest way to go about it. So you take 72 we just discussed now, it's 2 cubes times 3 square. You take 90, it's 3 square, 2 to the power 1, 5 to the power 1. I kind of like it to write it in this way, everything in one way. Once you have this, find the GCD. You can say that the GCD in this case is going to be, take the common prime numbers. So the common prime numbers are 2 and 3. And I told you in greatest common divisor, we take the smallest power. So we'll take the smallest power, in this case, this. So this is 18. So I'm saying that one of the divisors, n, can be 18. Okay. Keep in mind that here in this question, we are not told greatest common divisor. We are just told divisor. So 18 is one of the possibilities. That's very important to understand. So if this condition that is given here, if this was not given, okay, then 18 and all factors of 18. Remember, I told you to find out the total factors. How do you find out the total factors? You take the prime number, you add 1 to it, and you multiply it, right? So all the factors of 18 would have been the possible value of n. So in this case, let me even show it to you. And this is the way I write it, by the way. 1, 18, 2, 9, 3, 6. Okay. So all of these are possible value of n. Okay, if this condition would not have been given. Now, since we are given this condition that n has to lie between 9 and 30, then we'll say, hey, there's only one possibility, which is 18. So the correct answer in this case is going to be option B. I hope this is clear, guys. If you have any questions, please let me know. All of you got it correct, so I rushed a little bit, but I hope this is clear. So if they ask you about greatest common divisor, you find greatest common divisor. If you see the word divisor, you start off with GCD. If they ask you for all possible values, find GCD, then the total factors. If they give you a range, then choose within that which one would be your, which one would satisfy this given condition if the condition is there. Okay. Okay, great. I can see it's clear to everyone, which is perfect. So let's move on to the next one. Try out this one. And let me bring up the poll. So here, guys, I've added the poll. And again, you have 2 minutes. Please put the response in the poll only. Okay. Now don't put anything on the chat box. Questions. And if you want to understand the process, don't worry. I'll be obviously discussing it, so you'll get to know it. Okay, guys, I'm ending the poll now. I have enough responses. In fact, it's an interesting response because let me in fact just close the poll first. Okay, so it's a split almost between A and D, and one of them obviously is the correct answer. But here, some of you have fallen for a very small and a very obvious trap in this case. Okay, so let me talk about it. What's the trap out here? So what's the question? The question is n is an integer. Okay. And the question is n a multiple of 80? Now, what did I tell you? If you see n is a multiple of 80, what does that mean? That n by 80 should be an integer. Okay. Or the other way of writing it down is that n is 80 times k, because it is a multiple of 80. So the question is asking, is n equal to 80 times k, where k is some integer? Okay, so just a notation just to let you know. So I'm trying to figure out whether n can be written in this form or not. And this is a yes no kind of question, so I need to answer either yes or no. As long as I can answer either yes or no, that's good enough for me. Okay, so let's start off with the first statement. Again, keyword here, notice, is the word multiple. N is a multiple, so that should give you a trigger. Hey, maybe we might be dealing with an LCM kind of a question. And the moment you see two numbers, which says n is a multiple of 5 and 16, you should again in this case start off with the lowest common multiple. Keep in mind, when I say n is a multiple, that means a lot of multiples are possible, but the best way to approach this question is to start off by finding the smallest one. Okay, so you'll take LCM of 5 and 16, which is pretty easy, because in this case you'll say, I told you that you need to take both the prime numbers and you need to take their highest power. So the lowest common multiple turns out to be 80, which is good. So if n is a multiple of these two, the smallest value of n could be 80. Okay, but n could be any other multiple also, like 80, 160, 240, so on and so forth. So in GCD, what did I teach you? I taught you that first find GCD, then find factors, right? In LCM case, what happens is you find out the smallest number, and you know that n is a multiple, so it could be 81, 80, 160, 240. So you write it as 80 times some integer, okay, 80 times k, where k could be 1, 2, 3, 4, whatever value you put, you get all the subsequent values. So in this case, see, you're getting exactly what you want. You're getting n is equal to 80k. This is what you were looking for. So you can say this statement is sufficient because it is telling me that n is a multiple of 80. So far so good. At least statement 1 is sufficient. So your answer has to be either A or D. Rest of these cannot be your answer. Okay, so let's go to the second statement. Now, once again, n is a multiple of 8 and 10. Here also you should find the LCM. Those of you just looked at 8 and 10 and thought, okay, n would be divisible by 80. That is where you made a mistake. If n is a multiple of 8 and 10, that means the smallest value that is possible is basically, again, take both the prime numbers. Okay. Here you'll get 40. So you'll say n can be 40, 80, 120, blah, 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 blah. And how do you write it? I've just shown you the way to write it. So here you'll say n is 40 times, again, I'm using the k. Ideally, you should use some other variable, but just for the sake of explanation, n is 40 times something. Notice here very carefully that you are not getting 80 times something. So the question is n a multiple of 80? The answer could be yes. The answer could be no. For example, if n is 40, is 40 by 80 an integer? No, right? But if n is 80, then 80 by 80 would definitely be an integer. But you're not getting a concrete yes or no. You're not getting a definite yes or a definite no. In this case, the way you were getting it, you were sure that yes, n would be 80 or more than that. So it will always be divisible by 80. That is why we said this statement was sufficient. Here we are getting 40k. So it could be, could not be, depending on the value of n. So here you'll say, I don't know what's going to happen in statement 2. So this is not sufficient. And hence the correct answer in this case is option A. So keep in mind, don't just look at the number and simply multiply it. If you simply do 16 times 580, 8 times 1080, and then mark the answer, then you'll definitely fall for the trap and end up marking D, which would be incorrect. Okay, please let me know if this is clear or not, guys. Let me bring up the poll quickly. If you have any questions, please feel free to ask. Yes, Abby. So all the other multiples are multiples of the LCM. Okay, so the moment I get the smallest multiple, like in this case, once I get 80, all the other multiples, 160, 240, they will also be the multiple of these two numbers. Okay, so I hope that answers your query. Yes, this is close to 650. So I'll slowly, gradually increase the difficulty level. I can still see a few of you saying no. If there's any doubt, please feel free to ask. But I can see about 90% of you are saying that you have got this, understood this, I'm moving ahead. But if there are any questions, feel free to ask and I'll try to respond in the chat box. Philip, that's a good question, but please understand, I'm saying it separately. I'm saying it is a multiple of 8 as well as 10. So what this basically means is that n is divisible by 8 and n is divisible by 10. I am not saying that n is divisible by 8 times 10. I'm not saying that. I'm not saying n is a multiple of 8 times 10. It's saying that separately it is divisible by 8, separately it is divisible by 10. That is what it is saying. Okay, so if you look at it as a product, then that's a problem. Then you will think, okay, it has everything that I need. And that is where you'll fall for the trap. Okay, I hope that answers your query. And if still you have some doubt, then take the number 40. 40 is divisible by 8 separately, 40 is divisible by 10 separately. Okay, but it is not divisible by 80. So here's the third question, and let me bring up the poll. Here's the poll, guys. You can see I've written the equation form. If you want to copy it, you can for ready reference. And then I'm going to end the poll. This is again the reason behind choosing this question is while you're putting your response, let me just clarify it very quickly, is it's a variable based question where people just look at the variable and panic, and the first approach they start thinking about is, okay, can I take a number very quickly and try and solve this question? And that is where they fall for the trap or they end up spending a lot of time. But if you understand this definition properly, you should be able to solve this question in within 1.5 minutes, frankly speaking. And let me show you how. Okay, so I'm ending the poll. A good number of people have got this question correct, but I can see that a few of you have ended up marking B, C, D, E. So there might, I think, some confusion still left. So let me clear it out. Question is very simple. They're telling me that A and B are integers, and A is greater than 1, B is greater than 1. So they are integers like 2, 3, 4, whatever they bit. Okay, but they are integers. The question is A a factor of B? Now again, use the definition. If A is a factor of B, okay, then that means B by A should be an integer. Okay, so you should write this down. You should say, okay, if A is a factor of B, this is what I'm looking for. If I can get this, I can get my answer. Okay. Um, Yes, Abhi, you'll get the access to the recording. We usually mail the recording to you. If you want to access using the, YouTube channel, I'm just very quickly sharing the link of the YouTube channel. You can subscribe to it. Whenever we upload it, you will definitely get the notification. Okay. Okay. Coming back to the question quickly, guys. So this is what I'm looking for. If A is a factor of B, I need to figure out whether B by A is an integer or not. If I get an integer, I'll say yes. If I don't get an integer, I'll be able to say a no. So my task while working with the statement would be to try and see if I can get an expression which is in the form of B by A. That's all. So with this information, let's go to the first statement. First statement is A square plus A minus B is equal to 0. Now what I can do is I can take B to the other side and I can write B is equal to A square plus A, right? If I want, I can take A common from here and write it as A times A plus 1. And since I want B by A, I can divide by A both sides and end up getting B by A is equal to A plus 1. Now, can anyone tell me what is A plus 1? Is it an integer or not? A plus 1. We got the form that we exactly were looking for. We were looking for B by A. We got B by A. And on the right hand side, we got A plus 1. If you look at the question clearly states that A and B are integers. That means A plus 1 is an integer. Okay, so notice we got exactly what we want. We are getting B by A as an integer. So we'll say yes, A is a factor of B and this statement is sufficient. So can you see how easy it is? The moment you know what you're looking to find out, you just need to manipulate the expression, nothing else. You don't have to look for values, you don't have to plug anything. Just the pure play definition is more than enough. And obviously the skill of inference to get this answer. Same thing you need to do in the second statement, A square plus A minus KB is equal to 0. Take KB the other side. Once again, write it like this. Take A common. Now you need b by a, so divide both sides by a. But you don't know, you don't want this k here, so you bring the k to the other side, right? So at the end, you'll end up getting this. B by a is equal to a plus 1 by k. Now here is where things get tricky. The things get tricky because now here you have a plus 1 by k, and you don't know whether a plus 1 is divisible by k or not. You don't know whether this is an integer or not. A plus 1 standalone, we know. But what will happen when we divide it by k? Will we get an integer? Will it be a fraction? We don't know. Since we don't know what this would be an integer fraction, we'll say this statement is not sufficient because I cannot figure out whether it is a factor or not. So that's why the correct answer in this case is going to be option A. Is this part clear, guys? Did you see how easy it is? This is also a 650 level question, but I hope you can appreciate if you're able to set up the equation properly. And as I said, make this inference, because in this case, this inference is required. Some of you might end up taking values again, but there's no need to take a value and check. You can just say a plus 1 by k. I don't know what is a, I don't know what is k. It's quite possible I might get 5 by 3. It's quite possible I might get 6 by 3. I might get an integer. I might not get an integer. I don't know. So let's discard the statement, as simple as that. Okay. Okay, the good thing is I can see it's clear to everyone. All of you are saying yes, so that's perfect. So let's do one last question on this, and then we'll look at a question of total factors. So if you have understood factors and multiples properly, you should be able to get this one correct. And I'll give you 2.5 minutes for this one. Radhakrishnan, the outcome of integer by integer could be an integer, could not be an integer. Depends on what integer you're dealing with. So if you have, say, for example, if you have 6 by 3, then obviously that would be an integer. But if you have, say, 5 by 3, as I gave you an example, then it may not be an integer. Okay, so it depends. It could not be, depending on the number that you're dealing with. So I have a few responses. So I'm giving you about 1 minute more, guys. Post 1 minute, I'm going to end the poll. So far, most of you have got this one correct, which is good. Those of you are still trying, you have about 45 seconds with you. Okay, 10 seconds more, and then I'm going to end the poll. Okay, I'm glad to see the response. Frankly, it's a very good response. Most of you, I think, have got this one correct. Nikhil, this is a PS question because there are 5 options, so you just need to solve and get the answer. Okay. But as I was saying, the accuracy in this case, I think is pretty good. If I remember correctly, the answer is in fact D. So let's very quickly solve it. Once again, I'll use the definition what I've taught you, nothing else, nothing more. P is a divisor of Q. As I told you, divisor, factors, they all mean the same thing. So if P is a factor, then I would say Q by P, this must be an integer. Okay. This is something which I'll write down. Okay. Now I've been told that Q is the smallest. So the keyword here is smallest positive integer, which is a multiple of 36 and 100. So see, you have all the information that is needed, smallest multiple of 2 numbers. So I can say Q is LCM of 36 and 100. Okay, so all you need to do is prime factorize. 36 is 3 square, 4 square, 2 square, and 100 is 2 square, 5 square. Okay, and you will get Q is equal to, and as I told you, you need to take all the prime numbers that are there and take their highest powers. So Q is this. If you want to multiply and solve it more, you're more than welcome to do it. I'll keep it like this only, okay? Because I'm dealing with factors. I'm dealing with Q, so it is very easy for me to view which one could be Q, okay? The other information that is given to me is that P is less than square root of Q. So I'll write P is less than. I already know what Q is. I'll take the square root of this. Oops, square. So P turns out to be 2 times 3 times 5. So P is basically less than 30. Okay. Not sure how important this information would be. What we need to do is we need to find out which of the following could be. So I'm just looking for possibilities. Whenever you see the word could, that means they're trying to ask you, hey, tell me which one of them could be a possibility. Okay. Now let's look at the the statement that is given to me. P is a multiple of 10. P is a factor. Okay. P has to be less than 30, and I have to look for a value which divides this. So if it is a factor, that means this by P should be an integer. Okay. So can I think of a value of P which is a multiple of 10 and less than 30 and divides this also? It's very easy to see, right? I can look at it very clearly. I can see, okay, P could be 5 times 2, P could be 10, P could be 5 times 4, 20, multiple possibilities, right? So if the question, since this is a could be kind of a question, I can say, yeah, P could be a multiple of 10, P could be 10, P could be 20, and it would be a factor of Q. So this statement is definitely true. This statement could be true. Okay. If you have any doubts, please feel to ask. Second is P is a multiple of 15. Once again, look at this part. To get 15, what do I need? I need a 5 and a 3. Can I get a 5 and a 3? I can definitely get, right? I can say P is 3 times 5. So I can put P is equal to 3 and 5, and it will be a factor because I'll get an integer. So I can say, yeah, even this could be true because I can get an P could be 15. Now here is where the definition of multiple is important. Remember, I asked you a question, if what would be the multiple of 15, from where it would start. So I can start with 15 itself. So I don't need to check for higher cases. Some of you who might have discarded B, you might have thought, okay, if P is a multiple of 15, P has to be 30, 60, 90. If you started from 30, you would have looked at this condition and said, okay, this is wrong. So some of you might discard it if you don't, if you have forgotten the concept of multiple. If I ask you what are the multiples of 15, the first multiple would be 15, 30, 60, and this is it. So 15 also needs to be included. And I can see P definitely can be 15. It satisfies all the condition. It is a factor. It is less than 30. So this could be true. The third case is P is a multiple of 24. Now 24 is basically 2 cube times 3 to the power of 1. And notice Q does not have 2 cube. If Q does not have 2 cube, the factor, which is, the number that comes from this original number, it cannot have 2 cube in it. Because if I put 2 cube times 3 to the power 1, it will not divide. And I have been clearly told that P is a divisor of it. So it should divide. So I cannot have 24 or any multiple of P as a 24. So that is not possible. So I'll say this can never be true. There's not even a single possibility of this being true. So I'll discard this. So the first one is true. The second one is true. So the correct answer would be option D. If you have any questions, please feel free to ask. I'm putting a yes or no poll and I'm looking at the chat now. Let me see what kind of question you have. Mansi is asking which level is this? This is between 650, 700, I would say. Kelsey is asking, do we need to check the factors of 10? No, it's a multiple, right? So why would you check for factors of 10? If P is a multiple of 10, I would just figure out if P can be 10 or not. If P can be 10 or 20, that's enough for me. I don't even need to check for 20, 10 is enough. Yes, 0 is a multiple of a number. 0 is, in fact, a multiple of 0 can be written as any number, right? 0 times something is always an integer. So 0 is the multiple of everything. But as I told you, 0 will not be tested in GMAT, so don't worry about 0 at all. Kelsey is asking, I'm missing how we know for sure. I would assume I can just check 30. No, why would you check 30 by 10? See, understand, Q is P is a divisor of Q. So you have to look at Q. And then you need to decide what can be the value of P. So if P is a multiple of 10, I would check 10, 20 if I need to check, and I'll stop here because P is less than 30. So I will not go beyond that. Okay. I hope you've understood this, Kelsey. Thanks, Sudeep, for the compliment. Any other questions, anyone? I can see it's clear to most of you. I think only 1 or 2 people have said they haven't understood it. So please feel free to ask any questions that you want, guys. I'll be more than happy to answer them. But I hope now, at least if not 100%, but at least 70 to 60% is clear how you need to set up the equations and answer questions based on factors and multiples. Okay, now the questions that we are going to discuss are going to be slightly difficult. In fact, I've just taken one question on total factor, which I want to discuss. This is like the toughest version. If you're able to do questions like this, believe me, any variable-based total factors questions would be very easy to solve. Okay, so I've deliberately not put any easy question out here. This is the one question that we are going to do on total factors. I'll give you 3 minutes for this one. So take your time, give your best shot, and let me bring up the poll. So here's the poll, and you have 3 minutes. I'm just jotting down the total factors formula just in case if some of you were not present at the start of the webinar. So to find out the total factors, what you do is you prime factorize the number. P1 to the power A, P2 to the power B, you prime factorize it like this. And then to find the total factors, you take up the powers, you add 1 to it, and then you multiply them to get the total factors. Okay, so this is the concept that you need to keep in mind. This formula is like the key to solving this question. Okay, sure. Do let me know what that song is. If that helps, I'll share it with my students also. Not a problem. Okay, I can see I'm getting weird responses, so I'll just give you one small hint so that if you to nudge you in the right direction. So whenever you see a statement like this, okay, that some number has exactly this many number of factors greater than 1, then you should be able to infer that the total factor of that particular number would be, so if I'm saying 6 positive factors greater than 1, then the total number of factors would be 6 plus 1, 7. So that's the only small hint which I want to give you. How this is coming, I'll explain it to you, don't worry. But this is the meaning of this. So here, the first statement is telling you that n cube has total 7 factors. And the second statement is telling you that the total factors of 3n is 3 plus 1, 4. Okay. So keep this hint in mind and take another 1.5 minutes to see if you can do something with this. Okay, I'm ending the poll, guys. I can see, I think people are now, most of you are marking the answer as, in fact, I have equal amount of A, B, C, and D at this point of time. So let me end the poll. Let me explain this to you. I think that would be better. Okay. So as you can see, I have about 30% of you think the answer should be D. D, unfortunately, is not the correct answer. There's a small trap out here in statement 2, which some of you might have fell for, but yeah, I have the answer options are all over the place. Okay. No, given them, unfortunately, B is not the answer. B is not correct. Let me start by first of all talking about a few generic things to help you out. Okay. First thing which I want to talk about is what the meaning of this statement, because some of you might have got stumped with this. So I'll start off with a simple example. I'll start off with 10 only because that is what we took beforehand also. So we can see there are 4 factors of 10, right? Now, so in this case of 10, I can say 10 has exactly 3 positive factors greater than 1, right? Notice apart from 1, it has 3 factors which are greater than 1. And I already told you in the starting of the webinar that 1 is always 1 and the number is always present. Okay. So if a statement says that it has 3 factors greater than 1, that what they're telling you is apart from 1, there are 3 more factors. Okay. So if I want to find out how many factors are present, I would simply add, I would say, okay, total number of factors would be 3 factors plus 1, 4. Okay. I hope this part is clear. Any doubts in this one before I move on to the next generic thing which I want to talk about? Let me bring up the poll. Let me know if this part is perfectly clear. How am I deciphering what is the total number of factor for a number? Okay, good. Now let's talk about the next tricky part, which is, let's say even if I know that the total factor is 7, okay, what do I do with it? Now, this is where the total factor formula will come into picture, and I'll go really slowly here because I think this is frankly very tricky. Let me write down the formula once again. Okay, so those of you already know, please bear with me because as I told you, this might be a slightly difficult to explain. See, how do I get my total factors? I get my total factors by multiplying the powers, by adding 1 to it and multiplying it. Kelsey, subtract 1. Why would I subtract 1? See, they're telling me 3 factors greater than 1. So apart from 1, I have 3 more factors. So if I want to find out total factors, they're telling me 3 apart from 1, greater than 1. So I have 3 already which are greater than 1. If I want to find out how many of them are there, I need to add 1 to it, right? Then only will I get total factors is 4. So I won't subtract it, I will add it. Okay, because 1 wasn't being considered when I was taking the total factors. Okay. No, it doesn't matter how you write it. Okay, the sequence doesn't matter, by the way. Okay, Kelsey, so you can write it in whatever sequence you write it. You write it 1, 5, 2. I do that is not important. What is important is apart from 1, there are 3 more factors which are greater. So think of it in this way, not a problem. The sequence is not important. What is important is to just count 1, 2, 3. 3 factors greater than 1. There's 1 more which I haven't counted. So 3 plus 1, 4. Okay. Now, coming to this part, see, as I told you, we find out the total factors by multiplying the powers. So in the first statement, and for a moment now, just ignore n cube and 3n for a moment, okay? Let's think about the number only. Let's think about, let me write the number as, say, for example, capital X, okay? Think of it this way. Capital X has 6 positive factors greater than 1. That means its total factors is 7. Now think about it. You're getting 7 by multiplying some numbers because that's the formula that you're using. Okay, so can you tell me how do I get 7? How do I get 7 by multiplying these numbers? What could be the value of A, B, C? Can anyone tell me so that I get a 7? If this part, if you understand this part now, rest of the question becomes really easy. So can anyone tell me how do I get the total factor as 7? 7, keep in mind, as you can see, is a prime number. Okay. Ramnik says 7 and 1, 7 times 1. Very good. That's a very good response. 7 and 1, you can write 7 and 1. That's not a problem. Now, if I write 7 and 1, I'll be taking 8, A plus 1 times B plus 1. Take it, not a problem. Now notice, compare it. If A plus 1 is 7, then what is the value of A? A has to be 6. Okay. If B plus 1 is equal to 1, then what would be B? B would be 0. Right? Then only will you get, right? 6 plus 1 times 0 plus 1. Now, the moment you see B 0, what's happening here? If you make this 0, P2 to the power 0 becomes 1, right? And the rest of them obviously are not there. So ultimately, you are left with n is equal to P1 to the power 6, which most of you have frankly got it correct. You have mentioned that's just one of them, which is 6. Okay, the others would be 0, and that is the reason. So this is where I'm generalizing it for all of you guys. Okay, if this part is clear, generalize it for yourself. Whenever you are given the total factors as a prime number, okay, you should be able to infer that prime numbers can never be broken. So what that means is that n will always be in the form of P1 to the power a, nothing else. So if I tomorrow tell you that total number of factors is 5, you, instead of doing all these calculations, you can simply say, okay, 5, this is basically a plus 1. So that means n is going to be P1 to the power 4. That is the only possibility, nothing else. Okay, please let me know if this is clear or not. I'll keep on giving you yes or no questions because I don't want at the end people telling me they haven't understood. So if there's anything which is not clear, please ask now. That's a good time to ask. Okay, why am I telling you this? It will save you a lot of time. Tomorrow, if you see a total factor question, you will know which is our total factors is prime. You can just write it directly very quickly. Okay. Okay. So in this case, I know if the total factors is 7, I can write this as P1 to the power 6. And what is my number here? N cube. So I'll write it as N cube. This is my statement 1. So N cube is P1 to the power 6. I need to find out how many positive factors does N have. Okay, so I'll find out n. If n cube is P1 to the power 6, then n would be P1 square, right? You can divide the powers by 3, take cube root, whatever you want to call it. So n is P1 square. So the total number of factors in this case would be, just take the power, add 1 to it, and say 3. Since you're getting a unique response, a unique answer, you'll say statement 1 is sufficient. Okay, so your answer won't be B, C, or E. It has to be either A or D. Okay, so I hope the generalization form is perfectly clear. I'll even generalize it even further. If it is prime number, total factor, then n would be prime minus 1. Whatever that number is given minus 1, you do it, you get your answer. Okay, things get tricky. Okay, things will get tricky. In fact, let me see if I have a fresh slide. Or I don't have it. Okay, things would get tricky if you have non-prime total factors. Like in this case, notice total number of factor would be 3 plus 1, 4. So this is where let's discuss what's going to happen. So if my total number of factors is 4, can anyone tell me how can I get 4? If my total number of factors is 4, how can I get 4? What should I multiply to get 4? Anyone? I just noticed John's chat. Yeah, John, you're absolutely correct. That's the right answer. Okay, Nitish is also correct. Nitin, you are partially correct. Sudeep, again, partially correct. So in non-prime cases, remember, whenever you are given a non-prime number, and again, I'm trying to generalize it as much as possible for you so that you don't have to think a lot. You just remember the process and you can get the answer. In non-prime number, you always need to consider cases. And the first case is keeping the number as is. So keep 4 as is and say 4 is equal to, or say 4 times 1 if you want to. Okay. Here, if you keep 4 times 1, you'll get A is equal to 3, right? And B is 0. If B is 0, B is irrelevant. So you can say that your number n is basically of the form P1 cube. Okay, that is the first and the easiest case that you should always consider. Always keep the number as is and say this is going to be one of your cases. Okay, then you consider the second case, which all of you have, which is splitting it up. 2 times 2. Then you split it up. Okay, and then say A is going to be 1 and B is going to be 1. So n could be of the form P1 to the power 1, P2 to the power 1. Okay, so how do you remember this? You remember if it's a prime number, if the total factor is prime, you simply do n is equal to P1 to the power whatever that prime number minus 1 and you get your answer. Okay, if it's a non-prime number, you consider 2 cases. One case is you keep the number as is. That is the easiest case. Second case is when you split it up. Okay, in GMAT, don't worry, you will not get more than 2 splits, more than 2 cases. Obviously, in really difficult questions, there could be more than 2 cases, but in GMAT, you won't get it. So you won't get a question where total number of factors is 8, because then more than 2 cases can be created. But don't worry about it. Within the GMAT purview, these are the 2 major cases that you might come across: total factor prime, total factor non-prime, but the number would be small enough that you get only 2 cases, nothing else. Okay, so when they tell me that 3n has 4 factors, I would say my case 1 is 3n is of the form P1 cube. Okay, and my case 2 is 3 times n is basically P1 to the power 1 times P2 to the power 1. Okay, I'll pause here again for 10 seconds. Look at it. I'm adding a poll, yes, no poll. If this is not clear, please ask questions. If it's clear, please mark yes. Okay, that's pretty good. All of you are saying it's clear, so which is good. Now let's look at this case. Now in this case, notice left-hand side is 3 times n. And the right-hand side is P1 cube. There's only one prime number on the RHS. Okay, so obviously if on the left-hand side, I have 3 is the prime number, and the right-hand side, there's only one possibility of there being a prime number, then I can infer, right, that this prime number has to be 3 only. There's no other possibility. I cannot have any other prime number here. And I can say that n is then going to be 3 square. If n is going to be 3 square, my total factor is going to be 2 plus 1 equal to 3, which we got like in the first statement also. Remember, we got 3. So we are getting 3. That's one possible case. But here we have on the left hand side 3 to the power 1 times n is equal to p1 to the power 1 times p2 to the power 1. Now again compare. There are two prime numbers on the right hand side. Okay. One of them obviously will relate to this. The other one would be we can relate it to this. So we can say n is basically p2 to the power 1. If n is p2 to the power 1, then that means total factor is going to be 1 plus 1 equal to 2. Notice that in the second statement, we are getting two different cases. One case is where the total factor is 3, one case where the total factor is 2. And since you are getting two different cases, that is why we'll say this statement is not sufficient. And hence the correct answer is going to be option A. Okay, so I've spoken a lot. Please let me know if there's any doubt. I've generalized the process as much as possible. You can get a lot of PS questions on this, where they will tell you the total number of factors is 5, 4, and they might ask you to find out the number of, find out the value of n. So always remember that if there's a prime number, there's only one case would be possible, like we saw in this case. If it's a non-prime number, make two cases and that get the answer. Sudeep, you have to tell me from where. I am unfortunately not going to start from the starting. If you want me to focus on one part, please let me know. I'll definitely do that. Which part is not clear? Yeah, Pranjal, answer is A. Answer is definitely A, because we got one case here and here we got two different cases. Can you explain statement 2, case 1 again? Statement 2 again, okay. See, case 1 is where I'm saying that, so to get a non-prime factor, okay, non-prime like a 4, there are a number of ways of getting it. So think of one way is that you have a number which is in itself a prime number, nothing else. So let me give you an example that would be much more clear. Let's say if n is 3 cube, okay, if n is 3 cube, prime cube, then the total factor in this case is going to be what? 3 plus 1, 4. So this is one way of getting the total factors as 4. The other way is to get it like this. And again, this is a random example, but you could have 3 to the power 1 times 2 to the power 1, and this would give you 1 plus 1 times 1 plus 1, which is 2 times 2 equal to 4. Okay. So I'm saying whenever they give you a non-prime total factor, which is 4, always take two cases. One case is where you assume the number 4 as is. You take it as 4 and you equate it to one of them. And I'm removing this because this is going to create a confusion. Just simply take the number and equate it to just one of them, which relates to this case, which I've shown you here, assuming that there's only one prime number, nothing else. Okay, I hope this part is clear now. Second case could be where you split, because this is a non-prime number, you can split it into two halves, right? 4 can be written as 2 times 2. Tomorrow you might get a question which is based on 6, so it will be 2 times 3. So you break it down. And then you write it as 2 times 2 is equal to a plus 1 times b plus 1. Here, what am I assuming? I'm assuming that n is a product of two numbers, two prime numbers. Okay. And then you create your case and then find your answer. So here I figured out that n could be p1 cube, and I figured out that n could be p1 to the power 1 times p2 to the power 1. And then based on the question, like in this case, case 1 could be tricky, where I did it slightly quickly. Case 1 is 3n is p1 cube. So I equated it to this particular case. Now right hand side is prime cube. Understand this. This means prime times prime times prime. Obviously both of them are equal. If on the left hand side I have a 3, on the right hand side I should have a 3, right? So that I can equate it to them. The only way is when all of them are 3. Otherwise I cannot equate it. That's the inference that you need to draw. And then you cancel out this 3 and end up saying that n is equal to 3 square. So total number of factors would be 3. I hope that helps everyone. Philip, Sudeep, Abby, I hope that's now it's clear that why it has to be 3 square. I in fact covered everything. Let me see if there's any other question. Kelsey, so that's a very difficult question to answer. Could we have inferred S2 would be wrong just because you have two cases? Frankly, we don't know from both these cases what answer we would get. Okay, it all depends on the structure of the number that is given. Here it was given 3n. We ended up getting, two different cases. Now I might be given some other number here, which despite having two cases may end up giving me the same result. That is possible. That could be possible. So just saying that there would be two cases, so let me discard it, is like falling for that trap. Because GMAT might know that, hey, you might do that. So don't fall for that trap. Try and solve it. Do these again once again on your own. I would recommend this to everyone, especially if you got this incorrect. Try this question on your own once or twice so that the concept sets in. It's not easy. I'm telling you, it's not easy to understand. So you should definitely go through it once again. Okay. Yes, Karan, if you just stick to the definition, you can get the answer. There's nothing else that is required. What's PB saying? One question. So when we see that total factor is a prime number, then we can directly conclude it as sufficient as we do not have to split and solve. Yes, you don't have to split and solve. So obviously in that case, you can definitely do that because you'll be just getting one case. Since you'll be just getting one case, you know that you can break it down and solve it. That's absolutely correct. No, John, this is not a 650 level question. This is a 7 level question. I told you in the starting only that we'll be doing some difficult one. This is the most difficult one that you can get. But if you generalize the process, if you write it down your takeaway post this session and remember that, okay, in such questions, in primes we do this, in non-primes we do this. If you keep that in mind, it would be very easy to solve the question. Okay. Nikhil, in PS, we have 5 options where you need to kind of, mark one of them as correct. In DS questions also, we have 5 options, but you have to decide which statement would be correct. So there would be 2 statements. Depending on that, you need to decide which of the statement could be sufficient, either individually or both. Okay. 18. Yeah, it would be 6 only, right? 3 square times 2 to the power 1. So 3 times 2, yeah, then it would be 6. Okay. Nikhil, if you want more differences, I have an article. I'll just let me give you the next question and then I'll share that article with you. In that article, I've explained it very clearly what's the difference between them and everything. Okay. So you can read it in your spare time. Okay. Now, if you want to practice again, similar kind of questions, the one that I did now, if you want to, after going through the video, if you want to try it out again, there's a question in primes. This is for everybody, our GMAT Viz students, non-GMAT Viz students. You can go to the primes video lesson and there are quizzes called booster quizzes in primes. This particular question that I've shown here, again, notice it's a similar kind of question, 4 different positive integral factors, but this is a PS kind of question where I'm asking you to actually find out the number of integers, where I'm using the same technique to solve it. So if you want to, after going through the video, test yourself whether you're able to solve it or not, I would recommend going to the primes booster and trying this out. Okay, so that's it. There's one small announcement which I wanted to make since that was a difficult question. I'm sure you might need a break also. So just I would take about 5 minutes to make one announcement, which there's a new thing that we are launching in the month of March. And I thought it makes sense that, and this is something which even our students don't know. So I thought this would be a great place to announce it, that in the month of March, we are going to launch our GMAT Viz mocks. Okay, so currently we do provide courses and most of our students felt the need of having mock tests to, after completing the course to practice it. So before I talk about it once, I just want to understand, those of you who have taken mocks, whenever, if you haven't, that's also fine. But even if you have taken any test, what do you think is missing in those mocks, in those quizzes? What's the biggest challenge that you face after taking a mock? Let's say you've taken a mock, you see your score. Post that, what do you feel is missing in those mocks? Anyone? And again, there's no right and no wrong answer. I just want to understand, let's say you have taken a test. You took a test. It could be a mini test also. After taking a test, after taking a mock, you get a score. But what is it that you feel that is missing in those? Okay, John says analysis. Okay. Okay, feedback. Okay. That's a good explanation of the question I got wrong. Okay. And also the problem areas learning from next time for each section, more topic by adaptive nature. Okay, good answers. In fact, some of you have covered it, detailed analysis, evaluation of score like ESR, questions not represented. Okay, okay, rest assured, questions would be represented in our mocks, don't worry about it. Not much relevant score predictor except GMAT prep. See, that is a problem that Nitish, you'll face everywhere. So the main thing is that you should make sure that it predicts as close as possible. Even GMAT prep, frankly speaking, will not be able to predict accurately, at least the ones that you take the mocks. What I have realized and what the feedback most students that they give me is that whenever they take a mock, they get a score, but after that, they don't know what to do. As Nitin pointed out, evaluation of the score or a detailed analysis. What next? You see that you have got Q45 or Q47. What things do you need to study? What things you need to practice, right? That is something which is always missing in most of the mocks. So what we have done is we have tried to kind of cater to that fact. So we'll be giving you 5 mocks. We'll be launching on 15th of March. But the best part, which I think is that, say, if you're a GMAT Viz student, uh, you, your performance in the mock and when we're giving you feedback regarding that, it would be based, and the feedback that you get post the mock would be based on not only your mock performance, but your overall performance in general. Let me elaborate a bit on that. Say, for example, you are a GMAT Viz student, you completed a course, right? And then you go and take a GMAT prep mock, say, for example, or some other mocks XYZ. Now, you take a mock, you complete the mock, but you don't know what's the relation between whatever you have studied at GMAT Viz platform and the mock. And even the mock analysis does not take into account how well have you done in the course. Okay, so there's no way to find a relation between these two and to figure out what is the next step, what should be the next path. But in our case, what we are doing is whenever you complete a mock, okay, we do provide you obviously the usual things. And these are screenshots, okay. These are screenshots of our actual mock. We do provide you your actual score. We provide you obviously a quant and verbal score. But the best part about it is that we create a personalized recommendation for you. And when I say personalized recommendation, what I mean by that is this not only takes into account your mock performance, but it also takes into account the fact that how well have you performed in your courses. So we do a thorough comparison, thorough analysis between these two things to decide what should be the what should be the best things that you should be given to practice, or what are the topics that you should definitely go and study. Okay, and obviously this would be personalized for everyone. The way you're performing in the course would be taken into account. So you kind of get so once the personalization happens out here, okay, you get a screen like this where we kind of predict. Okay, we provide you some plan of action which nobody does at this point of time. No mock provides you what should you do next, which we will definitely be telling you. We'll be telling you what you need, what are the things that you need to practice questions from, what are the topics that you need to study. Each and everything would be elaborated very carefully below. And we also predict, let's say if we tell you, hey, if you complete these plan of action, if you're able to do it, by how much your score would improve. So this guy had a score of 620. Okay, so we are predicting that if you complete the things that we are telling you, you'll definitely jump from 620 to 690 easily. Your score from a V27 would improve to at least V34. So these kind of predictions are also we provide, telling you if you put in effort, the things that we are telling you, you will definitely improve. Like what are the things that you need to revise? These are things that you need to just practice questions, or you're already good in it, just practice questions and make sure that you improve your score in it. These are areas where you need to improve your concept also. So if I feel that your main point questions or inference questions are always where your score is less, then we definitely suggest this. As I told you, this is based not just on the mock performance. We also take your course performance into account. So we see, are you not doing well in your course also, and have you not performed well in your mock also? And there obviously, I'm simplifying it for you. There are other formulas that we have put into account to decide the priority order. So we tell you what you need to do. So that is like the plan of action that we provide you all. Okay, I can see a few questions. I'll come to all of them, don't worry. But just let me just complete this very quickly. Apart from this, guys, we give you detailed feedback on each parameter. So this is like the plan of action, but that's not it. So when you click on quant and verbal also, we will provide you a detailed feedback on everything. So if you want, you can look at your timing analysis of PS, DS, quant, how many you got correct, incorrect. We also give you a pacing versus accuracy feedback. And guys, these feedbacks are not standard feedback, just to let you know. It's not that I'll give the same feedback to everyone. The way you perform will decide what feedback you should be given. And frankly, this is one of the best things, the thing that I'm showing you here. We do a direct comparison of your course performance and mock performance. So let's say if tomorrow you want to know, a lot of students come and tell me, hey, I'm not understanding whether I'm improving or not. These mocks clearly show you that in DS questions in your course, you weren't doing well, but now in the mocks, you have definitely shown improvement. So this acts like a score, a confidence booster. You'll get to know, okay, I have been improving. I can see my geometry has improved. I can see my WP has improved. My DS has improved, and you can clearly see where you need more improvement. Okay, and we also give you feedback. We tell you exactly where you need to work on, in which order you need to work on, and these have been decided in a way which can maximize your score. Okay. So long story short, we give you feedback on each and everything. So these are at each and every part, you will be getting some feedback or the other, and all of these would be personalized. None of these would be, generic feedback that you will not be able to use at all. So as now coming to the questions out here. So one thing is that GMAT Viz students will be getting these for free. So those of you who are a current students, you will be able to avail this free of cost. You don't have to pay anything. Once we launch it, the plan is to launch by 15th of March, and you will definitely get access to it. And we will obviously send mails to you. Those of you who are not our students, obviously, we haven't decided. We may give you one mock for free, but we may not. But if you really want to, if you're planning to buy a course, if you're looking to prepare for GMAT, I would recommend now would be the time to buy it, because at this point of time, all these students would be getting these for free. Post we launch it, we may increase the price of our courses also. So if you want to know more about us in general also, I'm sharing a Calendly link if you want to talk to us, how we can help you prepare for GMAT. If you want to know more about the GMAT course or the GMAT mocks, you can use this Calendly link that I've shared here. Book a call with us, and we can let you know how we can help you. Yes, these are adaptive, so that is the reason we will be providing you with the accuracy, also pacing, also these kind of things will be provided to you, just to let you know how you're performing and what kind of accuracy difficulty level you are getting. Okay. So I would highly recommend to look at GMAT Viz, and if you, as I told you, if you want to talk to us, the Calendly link I've shared with you, just book a call with us and we can discuss it. No, Radhakrishnan, at this point of time, we won't be selling the GMAT Viz mock alone. Okay. Yes, Anish, this was just a small announcement that I wanted to make. If you have any questions regarding the mock or the GMAT Viz course, guys, feel free to ask me at the end of the webinar. There are two more questions which I want to do on LCM GCD, so that we kind of complete this webinar properly. So let's cover this, and after that, any questions, guys, just hold on to it for a moment. We would hardly take now 20-25 minutes, and once we're done with the questions, these two questions, we can start off with the discussion. Any question that you have regarding GMAT Viz. Now, coming back to the factors and divisors. Now, guys, whatever you have learned so far, that would be good enough for you to solve questions which are based on primes, divisibility. In LCM GCD, the core concept of LCM GCD is very easy. As you saw, you just prime factorize, take the common, take the highest. Everything is well defined. But GMAT knows that you know that. So what they'll do is they'll kind of tweak the question. Like you noticed in the total factor question, all of us know how to find total factor. So what GMAT does is they give us the total factors and then they ask us to find the number, right? That is how they confuse us. In LCM GCD also that is possible. So what might happen is they might give you a question like this, that m and n are positive integers, and they may tell you that the LCM of m and n is 6. Okay. Now, can anyone tell me if the LCM of m and n is 6, what could be the possible values of m and n? Can anyone tell me that? What would be the possible values of m and n? If the LCM of m and n is 6, what are the possible values of n? Now, give me in this format, right? 1, 6, 2, 3, if you want to give it. Okay, Karan says 1, 6, 2, 3. Nitish says 2, 3, 1, 6. Pooja says 2 and 3. Okay. Now this is where people just end up thinking 2 and 3 or 1 and 6. These are the most common answers that we get, and this is where the definition is very important. Okay. Think of it in this way: when you write, say, the LCM is 6, break it down. 6 as 2 to the power 3 to the power 1. So when you're deciding the values of m and n, what you need to do is you need to ensure that 2 to the power 1, 3 to the power 1 is present somewhere. Okay, it doesn't have to be present in both of them, but as long as it's present somewhere, you will be able to get the LCM as 6. Now let me tell you what I mean by that. So one of the possibilities, obviously, could be simply 6 and 6, right? I can have both 2 and 3 in both of them. Okay, this is one case which a lot of people miss. The other case could be 1 and 6, or 6 and 1, or 2 and 3, or 3 and 2, okay, or 2 and 6, 6 and 2, 3 and 6, 6 and 2, 6 and 3, sorry. So these are all the possibilities that you need to kind of think of. Obviously, GMAT will not ask you to think all of them, but there would be questions where you might have to use this concept to limit your number of cases. Okay, so don't just think that if the LCM is 2 and 3 and I'm dealing with M and N, then one of them will have 2 or the other would have 3. No, it's quite possible that M could have both 2 and 3, N could have just 2. It's quite possible that M could have 2 and 3, N could have just 3, and so on and so forth. So you have to think in these terms also. There is no theory as such around it, but I just wanted to let you know that don't just think of 2 and 3 when you're solving questions where cases are involved. Okay. Same goes for GCD. If I say that the GCD of NMN is 6, can anyone tell me what will be the value of M and N? This is slightly tricky, so think before telling me. If the GCD of N and M is 6, what is the value of M and N? Small hint, if you want, you can say we cannot find it out also. That's totally okay. Multiple, very good. Yeah, multiple of 6. Good. That's a good answer. If the GCD is 6, that means only the common part is 6. But there could be something uncommon in them, right? Like, for example, N could be 6 times 11, M could be 6 times 7, and the GCD could still be 6. So whenever you see that the GCD of N and M is given as 6, what you do is, and I'm telling you because you need to set up equations. You set up equations like this. You say N is equal to 6 times K1, M is equal to 6 times K2. This is how you set up your equation. And then you end up saying that K1 and K2 obviously are integers and they are co-prime. What do I mean by co-prime? What I mean is that K1 and K2 do not have anything common in them. That's the meaning of co-prime. So I cannot have something like this, 6 times 5 and 6 times 10. This won't work. K1 and K2 are different, but they are not co-prime. Why? Because if I write it like this, then the GCD would change. The GCD would become 6 times 5. Okay, so whenever you're writing the value of K1 and K2, you have to choose values of K1 and K2 such that they don't have anything in common. Or in short, the GCD of K1, K2 should be 1. If you want to really think in this way, you can think in this way that the GCD of K1, K2 should be 1. They should not have anything in common. Okay, so these are two things that you need to keep in mind when you're solving questions of LCM GCD. One is when you're given GCD, you set up equations like this. Whenever you're given LCM of two numbers, you think of all the possible cases before deciding what would be the answer. Okay. With this in mind, let's solve two questions. Let's start with this one. This is slightly on the easier end, and then we'll do one difficult question. Okay, so let me bring up the poll. I'll give you 2 minutes for this one. Okay, guys, I'm ending the poll in 10 seconds. I have got enough responses, so there, if anyone else wants to put in the response, please do so quickly. Okay, ending the poll now. Okay, most of you marked the answer as A, and I have a few E's. In fact, between A and E, one of them is the correct answer. Here also you need to focus on the definition, guys. Obviously, you need to know the definition of ratio. What it is given that the ratio of P and Q is 3:4. Now, what that means is that P by Q is equal to 3/4. That's one way of writing it. Or if you want, you can also say if the ratio of P to Q is 3:4, then P is 3x and Q is 4x. You can use any of these two forms to solve this question. Okay. Now, in this case, it would be better if we use this methodology because we want to find out the greatest common divisor. Now think about it. If I have the greatest common divisor of 3 times x, I don't know what x is, by the way, and 2 squared times x, and they're telling me that the GCD is 1, then that means they have nothing in common. But what I've done is I've assumed that there is x which is common in both of them. Okay. Now, if I look at the GCD, I would end up saying that GCD of 3x square, 3x and 2x square is going to be x, right? That because that is the only thing in common, and that is equal to 1. So this basically tells me that the value of x is going to be 1, which means the value of p is 3 and the value of q is 4. Hence, the product of p into q is going to be 12. Please let me know if this is clear or not. If there are any doubts, please feel free to ask. See, understand, whenever you're given a ratio as 3:4, that means after canceling out everything, the ratio is basically 3:4. So the best way is to write it as 3x and 4x. What I've done is I've already told you in GCD, we just take the common part. The common part in both of them is x. So I've said the GCD of 3x squared and 2 square times x is going to be x. So I've took that as x, and we already know that the GCD is 1, so I equated it to that. So those of you who ended up marking E, I hope it's clear now why the answer won't be E. If you have any questions, please feel free to ask. If it's clear, please mark yes. Okay. Once again, notice I'm setting up the equation to get the answer. I'm not checking any cases at all. What would have happened if they gave us another GCD? See, whatever they give us, I would equate that to it. So for example, if they would have given me that the GCD is, say, for example, 5, say, for example, then I would have said x is equal to 5. Left-hand side, I'll just take that as common. So x is 5. Okay. I hope this is clear, guys. Babu, 9 times 16, obviously the GCD you're correct is 1, but then the ratio of P is to Q is not 3:4. Okay, you have to maintain the ratio of 3:4. 9:16 and 3:4 are not the same thing. I hope that clears your doubt. If you want, obviously, Kelsey, you can take larger numbers and solve. That would also give you an answer. If you take P as 3, Q as 4, you get the GCD as 1. You can do that way also. You'll get 1. Now, if you take a higher multiple, like if you take P as 6, Q as 8, then you get GCD as 2. So you can say, okay, I don't need to take higher cases. If I take higher cases, then the GCD would not be 1. Since the GCD would not be 1, this is the only case which is possible. So that way also, if you want to solve the question, you can do it. It is slightly lengthy, but in this case, it would work. Okay. Julia, I hope that answers your query. If P is 6, Q is 8, then the GCD would become 2. We need to ensure that the GCD is 1. No, Karan, the ratio is always same. So if how do you get ratios? You get ratios by canceling out the common part. So if I have 6 is to 8, how do I get 3 is to 4? I get it by canceling whatever is common in it. Are you getting my point? So you're canceling this part to get 3 is to 4. So whatever you're canceling is always the same. So it always has to be xx, not x1 or x2. Okay. Once again, this has been explained in the ratio video lesson. If you want to go through it, definitely go through it. Where I've told you that whenever you're solving ratio questions, you need to do it in this way. This is an easy one. So let's go to the last question of the day, which is again a 7 level question. It's a good question. I'll give you 3 minutes to do it, and then we'll start the discussion. So give you your best shot, guys. Make sure to focus on the definition of writing P and Q, the one thing which I taught you. If the GCD of P and Q is 18, how would you end up writing it? If that part is clear, then you would be able to solve the question easily. Okay, 30 seconds more. for the trap in this one. A few of you have got it correct. Okay, I'm ending the poll now. So let's start the discussion. Can anyone tell me how did you write down what did you write down when you read the greatest common divisor of P and Q is 18? What did you do? Most of you have chosen C as answer. By the way, C and D, I don't think either of them are correct. D, I can still understand what most people have made the mistake. We have just made one small mistake. Those of you who marked D. Aditya, the answer to the last question, I think, was 12, if I remember correctly. P into Q. Okay. 18K1, 18K2. Okay, correct. So whenever you see, as I told you, if you remember these standard forms, you should be able to solve it very easily. You should be able to say that P is 18K1 and Q is 18K2. And either keep in mind or write it as somewhere that K1, K2 are co-prime. That means they should not have anything else common in them. Okay, that's a very important thing. And if you want, you can break it down like this. Okay. Now, LCM of P and Q is 630. So obviously we can write LCM of P and Q. If you remember, we prime factorize when I give you the simple question also. Here also I'm going to do the same thing. So I'm going to write it as, what would this give me? This would be 2 to the power 1, 3 square, 5 to the power 1, and 7 to the power 1, right? This is what I hope everyone got. Now, notice here that the LCM, and in fact, let me write the LCM, okay? Let me write the GCD also at the bottom, just to give you more clarity, okay? Notice that the GCD is 2 to the power 1 times 3 square, and the LCM is 2 to the power 1 times 3 square times 5 to the power 1, 7 to the power 1. That means this is common in both of them, which I've already taken into account, okay? This is not common in both of them, because if this would have been present in both of them, I would have got 5 here also, right? So one inference you should be able to draw is that 5 and 7, it's not present in both of them. Okay, that's a very important inference. Okay, how does that help us? It helps us in this way, is that now I can decide what are the possible cases or possible values of P and Q. So I need to give this 5 and 7 to someone, right? To either P or Q. I have to give it. In what way can I do it? Let me show you two ways. Case 1. I can write 3 square times 2 to the power 1 times, I give 5 to the power 1 to one of them, and 7 to the power 1 to the other one, right? I need to distribute it. I have to give this to either P or Q, right? I can give one of them to this, one of them to the other one. Okay. The other way is that case 2 could be that I keep this and I give 5 to the power 1, 7 to the power 1 to just one of them. Okay. So I pick this up and I give it to one of them. So the other number would just be 3 square times 2 to the power 1. Notice I'm keeping in mind that these two are co-prime. They should not have anything in common. That is the main key idea here to solve the question. Both of them cannot be 5. Both of them cannot have 5. Both of them cannot have 7. So if I have to give 5 and 7, either I can give them individually to one of them, or I can give the whole thing to the other one. Please let me know if this is clear or not, because if this is clear, then the question statements are really easy. You can solve it. Like I'll show you, but solving the statement would hardly take any time. Notice one thing, I deliberately did not write here P and Q, okay? Because either this could be P, this could be Q, or vice versa also, okay? Any of this is possible. So if you want to make 4 cases, you can make 4 cases, but I'm just writing down the cases out here, that either one of them is P, one of them is Q, one of them is P, one of them is Q. I don't know which one is which, okay? Now let's look at the statement. Statement 1 is P is a multiple of 35, okay? That means P must have 5 to the power 1 and 7 to the power 1 in it, okay? If P is a multiple of 35, that means P has to be this and Q has to be this, okay? I will not consider this case. I'll discard this case. I'll say, okay, this case is not possible. Why is this not possible? Because none of them can be P or Q. If I want P to be a multiple of 35, that means P should have both of them in it. It should have 7 also, 5 also. So I'll take up this case. I'll say, okay, this is the only case which is possible. Anyone has any doubt here, please let me know. Okay. Now let's look at case 2. Case 2 says that the GCD, or actually, in fact, what I've realized is the answer actually is D only. So most of you marked D is actually correct, just noticed. If P is a multiple of 35, that means P should have 5, and so this is sufficient. In fact, the second one also turns out to be sufficient only. So my bad, guys. Those of you marked D, you are correct. So GCD of QN35 is 1. So if GCD of QN35 is 1, think about it. Can I take case 1? If I take, for example, Q as this. If I take Q as this, then GCD of this and 35 would give me how much? It would end up giving me the GCD as 5, right? Because 35 and this have 5 in common. So I would say, okay, I want the GCD as 1. So obviously Q cannot be this, and even Q cannot be this. If I take this as Q, then the GCD of Q and 35 would turn out to be 7, because both of them would have 7 in common. So I'll say this case is redundant. This case is not possible. I'll discard this case. I'll say Q cannot be anything, so this is not possible. And if I want to make GCD as 1, then Q should not have 5 and 7 in it. That is the only way that is possible. So that means this would be Q, this would be P. Okay, so that means this statement is sufficient. Please let me know if there's any doubt, any questions, anything at all. Please feel free to ask. I can see about 10% of you are saying that you did not understand this. I'm again opening up the yes and no poll. If there's anything that you did not understand, now is the right time to ask. Keep in mind, the steps are universal and can be applied to most of the LCM GCD questions which are based on variable. If you stick to the process which I've told you, if you're writing GCD, if you write the generalized form, and if you make sure that you set up the equation this way, you know what are you looking for, what is missing, then it will be very easy for you to plug in the variables. If you remember this part, that in LCM, this 5 and 7 can be distributed anywhere. Okay, now I'm getting queries. In case 2, GCD is 18. Yeah, so GCD would be 18, right? Because the question says the GCD is 18. So I've ensured that the GCD does remain 18. That's not a problem. Sorry, I'm not sure what's your question. Sudeep, why would the answer be C? Now, I got answers from both of them, right? From first one also, I figured out that P has to be this and Q has to be this. From the second case also, I figured out P has to be this, Q has to be this. Why would it be C? Won't it be D then? Please, if you did not understand, Sudeep, please feel free to ask. What did you not understand? John, you're saying, can you repeat second statement where GCD of two numbers is 1? Okay, guys, read this carefully. They are telling me, in fact, forget case 1 and 2 for a moment. If this is making it tricky, look at each statement one and one. Okay, forget this. Let me make it more easy for you. They're saying GCD of Q and 35 is 1. What does that mean? 35 is 5 to the power 1, 7 to the power 1. If this GCD is 1, then the inference that you need to draw is that Q does not have 5 and 7 in it. Because if Q has 5 and 7 in it, then the GCD would not remain 1, right? If Q had a 5 in it, then the GCD would have turned out to be 5. So the inference that you draw here is that Q will not have 5 and 7. Now we have already decided when we're doing a pre-analysis, we inferred that we need to put this 5 and 7 somewhere. Okay. Now, if I cannot put this 5 and 7 in Q, that means Q does not have anything else. And this 5 and 7 needs to be placed here. Now, is this clear, guys? Now, hopefully, this should be perfectly clear. There should not be any issues at all. Please, I'm bringing up the yes and no poll again. Please mark yes if now this is perfectly clear. The inference from the second statement is Q does not have 5 and 7 in it. That is the reason that the GCD is 1. Okay, so if 5 and 7 is not present in Q, then this 5 and 7 must be present in P. And we're looking for P minus Q. Once we have P and Q, we can subtract and get the answer. Okay, Kelsey, you're saying, oh, so I'm assuming that you've understood it now. I hope that's the case. If there are any queries, please feel free to ask. If P is a multiple of 35, then it can be 35 or so. No, Babu, see, understand that if P is the problem here is I need to see 2 is already there, so I don't need to worry about 2. So even if it is a multiple of 70, I don't care. Okay, it could be a multiple. If it's a multiple of 35, if P is a multiple of 35, and I've already inferred that P has 2 in it. P has 2 in it, so it will be a multiple of 70. That's not a problem. In fact, P will always be a multiple of 70, Bhavuk, in this case. It will always be a multiple of 30. It has to be. There's no other option. And that is the case that I was talking about. The one that you have written here, P into Q is 18 times 630 times 18. That is the case that I'm considering also. If P is a multiple of 35, that means 5 and 7 must be present in it. So forget about the cases. Again, think in this way. Look at statement 1. P is a multiple of 35. Inference. What is the inference? Inference is P must have 5 and 7 in it. Right? If P must have 5 and 7 in it, I need to put it here. Okay, I put it. Now I already inferred 5 and 7 cannot be present in both of them because K1 and K2 are primes. If I'm putting 5 and 7 here, I cannot put 5 and 7 here. So Q will remain this only. So I'm getting the same answer. So even statement 1 is sufficient. I hope now it's clear, guys. Both these statements I've elaborately explained. I've removed the cases. I've just explained taking one statement at a time. So if you have doubts, please feel free to ask. Else, we'll end the session here. I'm sharing the our email ID and phone number. If you want to talk to us, if you want to, as I told you, know more about the course, please feel free to write to us. And I'll be there. I'm available for another 5-7 minutes. So if you want to ask me any questions related to GMAT, GMAT Viz, GMAT Prep, this is now the right time to ask, guys. Please feel free to ask me any questions that you want. You're welcome, Nitin. I'm once again sharing a Calendly link. If you want to talk to us later on also in detail about your GMAT prep, and if you want to enroll with us, work with us, I've shared the Calendly link on the chat. Please feel free to book a session with us, and we can talk how we can help you out. Apart from that, guys, feel free to ask any other questions related to your prep. You're welcome. I hope everyone liked the session. I hope it was useful. We will be sharing the recording hopefully on Monday. And so if you want to go through it once again, you can definitely go through it. Yes, Mansi, mocks are adaptive. So you don't need to worry about the adaptiveness. Obviously, the logic will not be exactly the same as the original one, but we have made sure that it works well. We have tested it out thoroughly, and it's giving really close results for a lot of our students. So we have done a beta testing for it, and it was working really well, and that is why we are rolling it out now. How much time it should take to prep for GMAT? Hari, that's like a very subjective question. It depends on person to person, and it depends a lot on your, initial prep. When I say initial prep, what I mean is how long have you been in touch with quant or verbal? Have you prepared before or not? How much time do you have in hand? A lot of factors are involved before you can decide. Ballpark number, if you want, I can tell that usually people take about 100 hours each for quant and verbal if you're preparing from scratch. Okay. 100 hours roughly, and then you may need to keep about 30-40 hours separately for mocks and other stuff. So that's about it. Is it better to appear before April, late, or after? Hari, depends in which timeline you're applying. If you're applying in round 1, then you can take it before, you can take it in June, July also. That's not a problem. You can definitely do that. Babuk, in QWizard, we currently have about 1,100 questions, in fact, 700 questions in quant, and about 450 in verbal. And we're continuously adding more questions. Okay, so it's not static. We keep on creating questions on a weekly, monthly basis, and we keep on adding new questions every now and then. So the number will keep on increasing only. And that's just Quizard, okay? You can understand for each and every topic, Bhavuk, we give, like there are 3 different quizzes for each and every topic, at least 3 different quizzes, okay? If I count the diagnostic per topic, then there are at least 4 quizzes. So that's about, think about it as 20-25 questions per topic separately that you'll get for each topic. So there are a lot of questions to practice from. Questions should not be a problem at all. Kelsey, you must have got a mentorship link, Kelsey. So you can use that mentorship link to schedule a call with me. Just check a mail from support, which must have been sent by me or Shreyas. Either one of us might be your mentor. So you can schedule a call with us separately. So those of you who do not know, we also provide mentorships along with these courses. So you can talk to us one-to-one also on a bi-weekly basis. So that's also one of the USPs of GMAT course. No, Nitish, unfortunately, the verbal course, people will not get access to mocks. The mocks is only for people who have access to both quant and verbal. Some of the quant is very it depends where you're preparing from and who's guiding you. Frankly, if you're preparing from the right resources, it should not be a problem. It may take more time. Some people prepare it in 1 month. Some people take 6 also. But if you follow the right methodology, as I told you, roughly 100 hours is what people take to improve. And you have to follow one course. And I'm not saying buy GMAT was. All I'm trying to say is just use one resource, use it properly, and make sure that you complete it end to end. It should not be a problem if you're using the right resource. Okay. You're welcome, Shubhankar. For our IR courses are not included in the course. We at this point of time we are not providing any support for IR and AWA because frankly it does not require a lot of effort. People usually prepare for IR a day or two before. For that we provide you resources, links which you can use to prepare from. So that is definitely covered. You don't need to worry about it. You just need to get in touch with us and we'll share all the resources with you. Okay. Yes, Mansi, questions in Quizlet are different from mocks. They're completely different. So 5 mocks, separate questions. Quizlet 1100 questions, separate. The questions that are in a course are also separate. So there's no dearth of questions, frankly speaking. Pavuk, yes, if you buy the course this week, the mocks will be given to you. Don't worry. As long as you buy it before the launch, it's free for everyone. Those who buy it before our launch. Carla, you can connect as long as you've completed sufficient amount of course to discuss. Okay, let's say, for example, you've completed one topic and then you want to discuss it with your mentor, then there won't be much to discuss. But if you're facing problems, you can definitely book a call and we can help you out understand what's the best way to prepare and how you need to prepare. Basically, the right way of learning stuff, we'll definitely guide you with that. That's not a problem. So if you're facing any issues, just write to us. Right material for GMAT. See, Samruddhi, depends. When you say right material, there are a lot of online courses. Obviously, if you want one end-to-end prep, I would recommend GMAT Wiz. If you don't want to use a course, if you just want to study free, not pay for anything, then it's slightly difficult because then you'll have to, go to GMAT Club, look for free topics, attend these webinars here and there, use the official guide and all those stuff to, prepare for the GMAT. And that's, frankly, it's not worth it. So in my opinion, buy a course. Up to you what you want to buy, but buy one, use that and complete it. Mansi, online live classes, most probably we may launch it in March end or April first week. The date hasn't been finalized yet. So, but we do have plans of launching it. But I cannot give you a date at this point of time. What you can do is once it comes up, you can obviously upgrade it. If you are not a student, you can buy the GMAT prep course at this point of time. And while you're preparing for it, once we launch the online class, you can upgrade to the live online classes whenever we started in the month of April or May. Okay. Any other questions, everyone? Anyone? And again, guys, I would highly recommend use the Calendly link. It's already broadcasted. I'm again sharing it again. I'm sharing it again. So if you want to, talk about your courses, talk about the course, about the Quizlet, mocks, any questions at all, feel free to book a call with us. But apart from that, if you have any other query, I'm here. Feel free to ask. You're welcome, Pranjal. I hope these sessions are useful for everyone. Faraz asking the question, the GMAT exam is more about, it's random topic, Faraz. It's not only about probability. There are about 20 different topics that are tested on the GMAT. Okay, and we cover almost everything, all of it. So if you want to, use a comprehensive resource where you don't have to look at 10 different things and study, you can look at GMAT Wiz and you can cover all the topics from one place if you want to. Probability is like just one question, maybe. PNC probability, 2 questions at the max. So the remaining 29 questions would be from different topics like primes, geometry, statistics, and all those places. Okay. Guys, I don't see any more questions. So if there are no more questions, then I am going to end the session. Once again, you can see the email ID on the screen. If you want to, write to us later on, feel free to write to us at support@gmatwiz.com. If you want to get in touch over a call, and if you want to ping us and discuss it, we have shared our WhatsApp number also. You can just write to us on WhatsApp, and we will get back to you. We'll give you a call. Okay. So see you tomorrow, guys. Tomorrow, as I told you, we have a webinar on pre-thinking. So if you want to, learn about critical reasoning, feel free to attend that session too. Okay. All the best, guys, and have a great day. Bye.